What if one of the most violent things in the universe isn't just killing galaxies, but secretly helping build new stars inside its own blast? That sounds backwards, almost offensive to everything we think black holes do. We picture them as cosmic endings, regions of no return, giant engines of destruction. But JWST is now staring at galaxies where the evidence points somewhere far stranger. Gas caught in a black hole-driven wind may be cooling, collapsing, and lighting up as newborn stars. The idea is simple and deeply unsettling. A supermassive black hole feeds. That feeding launches a powerful outflow. The outflow slams into gas. And under the right conditions, the same pressure that should sterilize a galaxy may squeeze parts of it into star birth. Creation and destruction, powered by the same mechanism, depending on where you stand. Astronomers call this positive feedback. Negative feedback is the classic version. The black hole heats or expels gas, shutting star formation down. Positive feedback is the rebel idea. Instead of only clearing the room, the outflow also compresses cold clouds until gravity takes over. Not despite the violence, because of it. And that matters because for years the story sounded clean. Big black holes regulate galaxies by starving them. Observations backed that up again and again. Fast winds, moving at hundreds to thousands of kilometers per second. Gas stripped out. Star formation quenched. Entire galaxies aging into red, quiet systems. Then came the uncomfortable details. In a few galaxies, astronomers began finding young stellar populations aligned with outflows. Not merely nearby, aligned with them. As if the black hole's breath had left behind a trail of ignition. One of the most discussed examples is the nearby galaxy Minkowski's object, long studied as jet-triggered star formation. More recently, systems like SDSS J1356 plus 1026 and the quasar host 4C41.17 pushed the question into more extreme territory. And now, JWST has made this harder to dismiss. Its infrared vision can peer through dust that used to hide the crucial scene. Not just the outflow, places inside it where gas is denser, cooler, and possibly young enough to still carry the fingerprints of recent star birth. In 2023 and 2024, multiple JWST studies focused on active galaxies with shocked gas, ionized outflows, and compact star-forming knots that older instruments struggled to separate cleanly. Personally, this is the part that stops me. We built a mental category called black hole behavior, and we assumed we understood the emotional direction of it. Feeding means destruction. But the universe does not care about our emotional categories. Pressure is pressure. Gravity is gravity. If a blast wave compresses the right cloud, nature may turn catastrophe into a nursery. To see why this is plausible, you have to zoom in on the mechanics. A supermassive black hole doesn't just swallow matter. As gas spirals into the accretion disk, some of that infalling material gets heated to extraordinary temperatures and drives energy back outward as radiation, winds, or narrow relativistic jets. These outflows can reach 1,000 kilometers per second, sometimes much more. That is roughly New York to Chicago in under a second. When that wind hits uneven gas in the host galaxy, several things can happen. Thin gas gets dispersed. Warm gas gets ionized, but denser pockets can be shocked and compressed. If those pockets cool fast enough, their internal pressure drops, gravity wins, and collapse begins. That collapse is the first chapter of star formation. Oh, so the same outflow can be both executioner and midwife. It can strip one region bare while triggering star birth in another only a few thousand light years away. That is the contrarian heart of this story. Black hole feedback is not a simple kill switch. It may be a sculptor. Brutal, selective, and strangely creative. There are real numbers behind this. In 2024, JWST observations of nearby active galaxies using NIRSpec and MIRI gave astronomers sharper ways to map warm molecular hydrogen, ionized gas, and dusty star-forming regions inside disturbed galactic cores. Earlier Hubble and ground-based work often lacked the combination of infrared sensitivity and spatial detail needed to separate young stars from gas merely glowing under the black hole's radiation. JWST can start teasing those apart. A study in Nature in 2023, led by Roberto Maiolino and collaborators, used JWST to identify a quasar in the early universe with a powerful outflow and signs consistent with compressed, dense gas in its surroundings. Other teams working on active galactic nuclei have reported outflows carrying enough momentum to rearrange the central few kiloparsecs of their galaxies. 1 kiloparsec is about 3,260 light years. So we are not talking about tiny local weather. We are talking about galaxy-scale pressure systems. If you had to choose, which version of black holes feels more true to you right now? Cosmic destroyer or chaotic builder? Tell me in the comments before the evidence gets even stranger. There is also a timing problem, and this is where the mystery sharpens. A bright, active nucleus can fake the appearance of youth. Its radiation can make gas glow in ways that mimic star-forming regions. So astronomers need more than a pretty alignment. They look for stellar ages, emission line ratios, gas density, motion, and whether the newborn stars are moving with the outflow, or simply sitting in the same line of sight. That is why this debate has lasted so long. Some apparent cases of black hole-triggered star formation fell apart under closer inspection. Others survived. The most persuasive systems are the ones where you see a chain. The outflow, the compressed gas, the shock signatures, and a young stellar population with ages consistent with the event. Not proof by coincidence, proof by sequence. Engaged? In my view, that is exactly why JWST is so disruptive here. It is not just giving us prettier images, it is closing loopholes. It sees through dust. It resolves structure in the infrared. It measures spectra across small regions with enough sensitivity to ask a harder question. Are these stars truly being born because of the black hole's outflow? Or are we just watching old stars through a dramatic fog? And the answer, at least in some galaxies, seems to be leaning towards something uncomfortably real. Not universal, not constant, but real. Under certain gas densities, cooling times, and geometries, the black hole may trigger the very process it is famous for suppressing. That forces a bigger rethink. We like stories where the universe assigns roles. Stars create light. Black holes erase it. Galaxies either grow or die. But on cosmic scales, those neat categories dissolve. The same supernova shock that destroys one cloud can trigger stars in another. The same plate collision that causes disaster on Earth also builds mountains. Why would black holes be exempt from that logic? But wait, there is a deeper reason astronomers care. If supermassive black holes can both quench and trigger star formation, then they are not just regulators of galaxies. They may be co-authors of galactic architecture. The shape of the bulge, the timing of starbursts, the chemical enrichment of future stellar generations. Maybe even why some galaxies matured so quickly in the early universe. That matters, because JWST has already shown us massive, evolved galaxies appearing surprisingly early after the Big Bang, in observations that stirred debate throughout 2023 and 2024. Some of those findings were later refined, but the central discomfort remained. Parts of galaxy evolution may be happening faster, messier, and less linearly than we expected. If black hole outflows sometimes accelerate star formation instead of only shutting it down, that could help explain bursts of rapid assembly in certain environments. In other words, the thing we thought was the galaxy's executioner may occasionally be stepping on the gas. Can you imagine how eerie that is? A region near a ravenous black hole should feel like the least hospitable place for creation. Yet a few thousand light years out, inside the turbulence it launches, new stars may ignite. Blue, hot, young stars, born from gas that was crushed by an engine we usually describe as apocalyptic. Confesso, when I first dug into this, I expected a niche technical dispute. Instead, it felt philosophical. Because from a human distance, we separate violence and creation into opposites. The cosmos often doesn't. A collapsing cloud forms a star by losing its old form. A star seeds heavier elements by dying. A black hole wind may erase one future and trigger another. Maybe that is the unsettling lesson here. The universe is not built around our moral categories of gentle and brutal. It is built around energy, density, time, and scale. Move close enough, and something looks destructive. Step back far enough, and the same event becomes fertile. There is still caution here. Astronomers are not claiming every active black hole is a star factory. Many clearly suppress star formation. Some evacuate gas so efficiently that they help shut entire galaxies down. Negative feedback remains essential to modern galaxy evolution models. The challenge is that the clean, one-direction story is breaking. The evidence now points to a spectrum where black hole feedback can hinder, trigger, or alternate between both depending on conditions. If that idea scrambled your mental image of black holes even a little, leave a like. Just this one possibility, that a galactic killer can also light stellar nurseries, deserves more attention. And there is one last twist. If astronomers confirm more examples, the phrase black holes kill galaxies will still be partly true. It just will not be the whole truth. The deeper truth may be harder to live with. Black holes do not simply end things. They redistribute possibility. They destroy in one place, compress in another, and force matter into choices it would never make alone. So when JWST looks into these violent galactic hearts, it is not merely watching monsters feed. it may be catching the universe using the same hand to tear and to build. And personally, I think that is more awe-inducing than the old story. A universe where destruction and creation are opposites is dramatic. A universe where they can be the same mechanism, seen from different distances, is far stranger. The next time you hear that a supermassive black hole is blasting material across a galaxy, remember this. Somewhere inside that violence, a star may be beginning. If this kind of cosmic paradox is exactly why you love space, subscribe and turn on the bell. Out here, the universe keeps getting less intuitive and much more beautiful.